My dear students of Standard 9, good afternoon everyone. Dear students, we are talking about chapter 6 from your chemistry book. Already we had completed mole, molar volume, percent composition and molecular formula from this chapter. Today in this class we will discuss about chemical chains, chemical reaction, chemical equation and its balance. So at first, chemical chains. Dear students, you know there are two types of chains, physical chains and chemical chains. In physical chains, only the physical appearance is changed, but in chemical chains, the substance is converted into a substance of new properties. Its property is completely changed. Here, the chains in which a substance is converted into a new substance of different properties is called chemical chains. Now, what is chemical reaction? Chemical reaction is the process that brings the chemical chains in a substance. The process that brings the chemical chains in a substance is called a chemical reaction. Now, what is chemical equation? Chemical equation is the short expression of chemical reaction. This short expression is expressed by using symbol, formula and sign. Sign means plus, minus, equal, arrow sign, these things. That means what is chemical equation? The short expression of a chemical reaction using symbols, formula and sign is called chemical equation of that reaction. Now, in chemical equation, you know that there is a sign, arrow sign or equal sign, and in left side there are some substances and in right side there are some substances. The substances, elements or compounds that remain in the left side are called reactants, and the substances that remain in the right side are called product. So, what is reactants? Reactants is the substance or substances that are used to begin a chemical reaction are called reactants. Reactants start the chemical reaction. These are used to begin a chemical reaction, and these are placed at the left side of the chemical reaction, of the chemical equation. Now, what is product? Products, the substance or substances with new properties that are formed at the end of the reaction are called products, which are placed at the right side of the equal or arrow sign. That means reactants that start the reaction and products that are formed after the reaction. Now, how to write a chemical reaction? Rules of writing chemical reaction. There are some rules. In a chemical equation, the formula or symbols of the reacting substances or reactants are written on the left of the sign of equality or arrow, and the symbols or formulas of the products are written on the right of it. That means, look, reactants, these are placed at the left side, and products that are placed at the right side. For example, when the reaction is calcium carbonate is heated to produce calcium oxide and carbon dioxide, that means the reaction is started by using calcium carbonate. Here calcium carbonate is the reactant, and calcium carbonate CaCO3 will be placed at the left side of the equal or arrow sign, and the products calcium oxide and carbon dioxide, these are placed at the right side of the equal or arrow sign. But the reaction, if it is like this, that calcium oxide and carbon dioxide, they react to produce calcium carbonate. That means you started the reaction by using calcium oxide and carbon dioxide. So here these two are reactants. So calcium oxide and carbon dioxide are placed at the left side of the equal sign, and they produce calcium carbonate. So calcium carbonate is the product here. Calcium carbonate will be placed at the right side. Look, the two reactions are not same. In first reaction, calcium carbonate was the reactant, but in second reaction, calcium carbonate is the product. In first reaction, the products are calcium oxide and carbon dioxide, but in second reaction, calcium oxide and carbon dioxide are the reactants. Now, 2 number rules. If the reactants or products are more than one, a plus sign is put between the formula and the symbols. If there are 2 or more than reactants, or if there are 2 or more than products, then between these reactants and between these products, one plus sign will be put like this. Look, here there are 2 reactants A and B. So this plus sign is put between this A and B, A plus B. And there are 2 products C and D. Here also one plus sign is put, C plus D. Now, if the number of molecule is more than 1, then the number is used before the formula. Look here, there is 1 mole A, 1 mole B, 1 mole C and 1 mole D. But if the mole number is more, if the molecule number is more, then this mole number is used before the symbol or formula of the reactants and products like this. Here look, here 2 mole A and 1 mole B. So these 2 is seated before A. Here the products are 1 mole C and 2 mole D. So here there is placed 2. An arrow sign is used to indicate that the reaction moves towards the products from the reactants. Instead of an arrow sign, an equal sign may also be used. However, the equation has to be balanced on both sides. Look, in these reactions, here arrow sign is put. But instead of this arrow sign, you can put equal sign also. But for putting equal sign, you have to balance the reaction. Without balancing the reaction, equal sign will not be put. The number of atoms of different elements present in the reactants before chemical reaction must be equal to the number of atoms of different elements in the products formed after the reaction. And to do this, we have to balance the symbol or formula of the reactants and products. And to balance the reaction, we have to multiply the formula and symbol of reactants and products by the required number. That means you can put equal sign, but to put equal sign you have to balance the reaction. Balancing means the number of atoms of reactants and products must be equal. You know, in a chemical reaction, no new substance is formed or no substance is destroyed, finished. So, in the reactant side and in the product side, the mole number must be equal, atom number must be equal. And to make this equality, we have to multiply the symbol or formula by the required number. For example, water, hydrogen and oxygen, they make water. Look, H2 plus O2, H2O. This is the reaction. But if we write H2 plus O2 product H2O, then this equal sign cannot be put here. If we give arrow sign, that is okay. But sometimes the reaction must be balanced. Look, when you will write H2 plus O2 H2O, that means there are 2 atoms hydrogen and 2 atoms oxygen on the reactant side. And the product side, there are 2 atoms hydrogen and 1 atom oxygen. But here in the reactant side, there were 2 atoms oxygen. So hydrogen is balanced here, but oxygen was not. So what will we do? We will multiply this water into 2 because we have to make this oxygen 2. But after multiplying, now oxygen is balanced, but hydrogen, now it is 4 atoms, but in the product side it was 2. So we will multiply this hydrogen also with 2. Now there are 4 atoms hydrogen and 2 atoms oxygen. Products also 4 atoms hydrogen and 2 atoms oxygen. Now we can put this equal sign. Some more rules are: sometimes the physical states of both reactants and products are also mentioned in an equation. Physical states means the reactants and products are solid, liquid, gaseous, or in aqueous solution. And this physical state is written on the right side by using first bracket. It is written on the right side of the reactants and products using first brackets like this. If the reactants and products are solid, then we will use S, small s, like this. If they are liquid, we will use small l. If they are gaseous, we will use this G. And when the substance is in aqueous solution means in watery solution, then we will write AQ like this. Look, here hydrogen plus oxygen, water. Hydrogen, it is gaseous, so we will write here G. Oxygen, it is also gaseous, we will write here G. And water, it is liquid, so there is written L. In a chemical reaction, heat has been produced or absorbed. Sometimes this produced or absorbed heat is to be shown with plus sign or minus sign with products. In a chemical reaction, either heat has been produced or heat has been absorbed. And if heat is produced, then we will write plus heat with product. And if heat is absorbed, then we will write minus heat with product. Like this. Look, carbon plus oxygen, they produce carbon dioxide plus heat, because in this reaction heat is produced. But this reaction, look, nitrogen plus oxygen, they produce nitric oxide. Here heat is absorbed. So here we have written minus heat. Look, this production or absorption of heat in every reaction it is occurred. But every time no need to show this heat. But for some cases we have to show this heat in reaction. Here heat is produced, and we know in the reaction where heat is produced, they are called exothermic reaction, and here heat is absorbed, that means it is endothermic reaction. We will learn about this exothermic reaction and endothermic reaction in our next chapter. Some reactions are there that require heat to be applied. The heat is expressed with a delta sign above the arrow mark. For example, when calcium carbonate or potassium chlorate are decomposed, how they are decomposed? By heating. When calcium carbonate or potassium chlorate are heated, then they decompose, and calcium carbonate produces calcium oxide and carbon dioxide. After heating potassium chlorate, it is produced potassium chloride and oxygen. So here heat is given to decompose this. This heat is expressed with a delta sign above the arrow mark like this. Look, here this delta sign, it denotes that calcium carbonate is heated and they produce calcium oxide and carbon dioxide. Now look, the main objective of a chemical equation is to express which reactants are participated in a reaction and which products are produced. So it is not always necessary to balance a chemical equation. Our main objective of a chemical reaction is to express the reactants and products. For example, in this reaction, if you write carbon plus oxygen CO, then totally it is wrong. If you write H2 plus O2, H2O2, then the total reaction is wrong. So our main objective is hydrogen and oxygen are the reactants and water is the product. But balancing, it is not necessary every time. But in this chapter, in next classes, we will do the math. For doing this math, balancing is very, very important. Without balancing, you cannot do the math. So, for some reactions, for some purposes, you have to balance the reaction, but not in every cases. Now we will learn how to balance a reaction, balancing chemical equation. Now, sodium reacts with sulfuric acid and produces sodium sulfate and hydrogen. From there, you understood that here sodium and sulfuric acid are the reactants and sodium sulfate and hydrogen are the products. So at first write the reaction sodium plus sulfuric acid, the products are sodium sulfate plus hydrogen. But look, here I put arrow sign. Why? Because the reaction is not balanced here. Look, here there is only one atom sodium, but in product side there are 2 atoms sodium. Sulfate and hydrogen, these are balanced. Here sulfate, totally sulfate we will balance because in the product side this SO4 is not broken. When a radical is broken from reactant to product, then we will balance atom to atom. Otherwise, we will balance the full radical. Here sulfate is balanced, hydrogen is balanced, only sodium is not. So we will balance only sodium here. There are 2 atoms sodium, but here there is only 1 atom. So what will we do? We will multiply this sodium with 2. That means we will put 2 on the left side of this sodium. Now the reaction is balanced. Now you can give equal sign. In this time you can give equal sign or arrow sign. Both are correct. But in the first reaction, if you give equal sign, then it is totally wrong. Another reaction, calcium carbonate is decomposed or broken and produce calcium oxide and carbon dioxide. Look, calcium carbonate, it is decomposed and the products are calcium oxide and carbon dioxide. Look here, calcium, carbon and oxygen. 1 atom calcium, 1 atom carbon, 3 atoms oxygen. And in the product side, 1 atom calcium, 1 plus 2, 3 atoms oxygen and 1 atom carbon. Every atom is balanced here. So the reaction is balanced and you can give both equal or arrow sign for this reaction. This reaction I have shown before, 2 atoms hydrogen, 2 atoms oxygen, but 2 atoms hydrogen, 1 atom oxygen are in the product side. So we have to balance the reaction. Now at first we balanced here only oxygen by multiplying this water into 2. But after this we saw that the oxygen is balanced now, 2 and 2. But now in the product side there are 4 atoms hydrogen and in the reactant side there are only 2 atoms hydrogen. So the reaction was not balanced here. So we will do what? We will multiply this hydrogen also by 2 and now the reaction is balanced. Now how will you understand the reaction is balanced? You have to count the atom number in the reactant side and in the product side. Left side, hydrogen 2 into 2, 4 atoms, oxygen 2 atoms, and in the right side, hydrogen 2 into 2, 4 atoms and oxygen 2 into 1, 2 atoms. So hydrogen and oxygen both are balanced. Left side equal, right side. Therefore the equation is balanced. In this way you can verify the reaction is balanced or not. Again, look here, there are 2 atoms nitrogen and 2 atoms hydrogen, but in the product side there is 1 atom nitrogen and 3 atoms hydrogen. Now for this reaction, if you want to balance at first hydrogen, this is difficult for you because there are 2 and there are 3. So at first we will balance nitrogen. There are 2, there is only 1. So what will we do? We will multiply this nitrogen, this ammonia with 2. Look, now 2 atoms nitrogen, here also 2 atoms nitrogen, but now in the product side there are 6 atoms hydrogen, but in the reactant side there are only 2 atoms hydrogen. So this was not balanced. Now we multiply this hydrogen also by 3. Now 3 to the 6, and here also there are 6 atoms hydrogen, so the reaction is balanced. Look, this reaction here, potassium chlorate is decomposed and produce potassium chloride plus oxygen. Here also potassium and chlorine both are balanced, but oxygen, there are 2 atoms oxygen, but in the reactant side there are 3 atoms oxygen. So to balance this oxygen 2 and 3, if we make both of them 6, then the reaction can be balanced. So to make this oxygen 6, we have to multiply the potassium chloride with 2, and we have to multiply this oxygen by 3. So we did this here. Now look, oxygen 6 atoms, here also oxygen 6 atoms. Now oxygen was balanced, but at first the potassium and chlorine, these were balanced, but now they are imbalanced. In the reactant side 2 atom potassium and 2 atoms chlorine, but in the product side 1 atom potassium and 1 atom chlorine. So we will multiply this potassium chloride also by 2. So now the balanced reaction is 2 potassium chlorate and 2 potassium chloride plus 3 oxygen. Now look, every atom is balanced here. Another reaction, methane plus oxygen, and they produce combustion of methane. So combustion of every hydrocarbon produce carbon dioxide and water. And look here, carbon 1 atom, carbon is balanced. Hydrogen 4 atoms, but there are 2 atoms not balanced. Oxygen 2 atoms, and there are 2 plus 1, 3 atoms not balanced. At first, what will we balance? 3 and 2, it is difficult, so we will balance hydrogen at first. If we multiply this water by 2, then hydrogen would be balanced. We had to multiply it here. Now hydrogen 4 atoms, carbon balanced, but oxygen 2 plus 2, 4, but in reactant side there are only 2. So now it is easy. If we multiply this oxygen by 2, then it will also be 4. So this is methane plus 2 oxygen, carbon dioxide plus 2 water. Now look, every atom is balanced here. So dear students, you will practice every reaction in your book, or you will see anywhere to balance this reaction. Okay, and I will give you some reaction to balance here. This is your homework. These reactions, these 4 reactions, you will balance in home. So dear students, today up to this, goodbye everyone. Thanks to all. See you in next class.